Welcome to the deep dive. Today, we're jumping into something pretty wild.
Really wild, yeah.
Building cities inside wormholes. It sounds like pure sci-fi, right? But theoretical physics kind of allows it, at least to think about seriously.
It does, remarkably so. And we've got some fascinating sources here guiding this deep dive, looking at the science, the speculation, the sheer ambition around wormhole cities, building colonies, and space-time shortcuts.
Right. So our mission today, specifically for you listening in, is to really unpack this incredibly complex idea. We want to cut through the maybe theoretical noise.
Get to the core concept.
Exactly. Understand the physics needed, explore the immense engineering challenges, think about the staggering implications for, well, any civilization.
And ultimately see if the sci-fi staple could, maybe, just maybe, inch towards reality someday.
Let's really dig into what these sources lay out. Okay, so first things first, let's kick things off with a quick level set. What is a wormhole, really, in this context we're discussing?
Fundamentally, it's what's often called an Einstein-Rosen bridge. It's a theoretical structure within space-time itself.
So like a tunnel.
Think of it like a tunnel, yeah. Or a shortcut connecting two incredibly distant points. Points that could be light years, maybe even galaxies, apart in normal space and time.
Right, like folding a piece of paper and poking a hole through instead of traveling all the way across the surface.
That's a very common analogy, and it captures the idea well. The concept actually emerged from solutions to Einstein's own field equations.
Oh, really? From Einstein himself?
Well, from his theory, general relativity. Back in 1935, Einstein and Nathan Rosen explored these solutions and found they allowed for these, well, theoretical bridges.
So they've been mathematically possible for a long time, and what could they connect? Just 2 points far away in our universe.
That's one possibility, yes, connecting vastly separated regions of our own cosmos. But the theory, as explored in the sources, suggests maybe more.
More like,
Potentially linking entirely different universes.
Yeah.
Parallel realities, perhaps.
wow, okay.
And the most reality-bending one, connecting different points in time.
Different times. Okay, yeah, that's where things get seriously strange fast. But there's a huge catch right off the bat, isn't there? These aren't just sitting out there stable and ready to use.
Oh, absolutely not. That's the crucial point. The standard, simple Einstein-Rosen bridges, they are incredibly, fundamentally unstable.
How unstable.
They'd pinch off and collapse faster than anything even light could possibly cross them. We're talking essentially instantaneously.
So no practical use for travel or anything else then, in their basic form.
Not at all. Which means to even begin thinking about using one, let alone, building in one,
Yeah.
you need something extraordinary to hold it open.
Something to prop the door open, basically.
And this is where some really foundational work comes in, work our sources point to, like that 1988 paper by Morris, Thorne, and Yurtsever.
Ah, yes. What did they figure out?
Well, it was a bit of a breakthrough because they showed, mathematically, what might be needed to make a wormhole traversable, something you could actually pass through.
Okay.
And the key, the absolute requirement they identified, was the need for something called exotic matter.
Exotic matter. Sounds suitably mysterious.
It is. They looked at the energy conditions required and found you'd have to violate something physicists call the weak energy condition, right at the narrowest part, the wormhole's throat, to counteract the collapse.
Violating an energy condition, that sounds difficult.
It certainly does.
Yeah.
But it was a pivotal moment. It shifted the thinking from wormholes exist in math but are useless to, well, maybe, just maybe, we could make them usable if we had this specific, very weird stuff.
Okay, let's dig into this exotic matter then. Is it just antimatter or something else entirely?
It's fundamentally different. Antimatter still has positive mass, positive energy density, just opposite charge. Exotic matter, in this specific context for holding wormholes open, needs to have negative pressure, or even more strangely, negative energy density.
Negative energy density. How does that even work? It's like having less than zero energy. Does anything like that actually exist?
It's deeply counterintuitive for sure. Think about normal matter and energy. They curve space-time in a way that creates gravity, pulling things together, making a wormhole want to collapse inwards.
Right. Gravity pulls.
Exotic matter, with this negative energy density property, would curve space-time the opposite way. It would essentially push space-time apart, acting like anti-gravity right where you need it to counteract the collapse and keep the tunnel open.
So it repels instead of attracts in terms of space-time geometry.
It's the effect, yes.
Right.
Now, have we found big lumps of this stuff just lying around? No.
Ah.
But, crucially, The concept isn't completely forbidden by physics as we understand it. It's not pure fantasy.
So there are hints of it, maybe, places where similar ideas pop up.
Yes, and the sources do point this out. For instance, the Casimir effect. It's a real, measured quantum effect where negative energy density can appear in the tiny space between two very close conductive plates.
Really, actual negative energy.
In that very specific quantum context, yes. And also, some models trying to explain dark energy. The thing accelerating the universe's expansion involves something that behaves a lot like negative pressure on cosmic scales.
Okay, so it's not totally out there. Physics allows for these kinds of effects in certain regimes.
Exactly. They aren't the exact stuff needed for a wormhole ready to go, but they show the underlying physics isn't impossible.
So if we could somehow get our hands on or manufacture vast amounts of this exotic matter, what's the next step? What does engineering a wormhole actually involve, according to the sources?
Well, the sources, like Visser's book on Lorentzian wormholes, make it clear it's a monumental undertaking. First, you'd need truly enormous quantities of this exotic material, not just a sprinkle.
How much are we talking?
Hard to say precisely, but likely astronomical amounts. And beyond just having it, you'd need unprecedented control over fundamental forces, over gravity itself shaping spacetime.
And quantum fields, too.
And quantum fields, yes, which govern matter at the smallest scales. The challenge isn't just finding the ingredient, it's becoming master architects of reality itself. Being able to actively construct, manipulate, and then constantly stabilize these incredibly complex space-time geometries.
You're talking about stitching space-time, tailoring the fabric of the universe.
That's essentially what it would be, yes.
All right, let's just take that enormous leap. Let's imagine for a moment that a civilization could do all that. Get the exotic matter, master the physics, stabilize the wormhole. What then? What does a city in or near a wormhole look like? How do we go from theory to, well, habitation?
This is where the sources really lean into the speculative but grounded possibilities. If you have stable, traversable wormholes, these cities or outposts would be located, quite literally, within or immediately next to that stabilized tunnel through spacetime.
And the killer app, the main advantage is
Instant connection. Suddenly you're linked to a point that could be light years away. Another star system, another galaxy, maybe even, as we said, another time or universe, without the long journey.
you step through a door and you're Daxter. Somewhere else entirely. That changes everything. For logistics, for civilization.
Everything. Imagine interstellar trade, resource movement, communication, all happening instantly.
What about the environment itself, though? Inside or near the wormhole throat? Would it be nice or inherently dangerous?
That's interesting. The sources suggest some potential benefits to the location beyond just the shortcut. Being inside that intensely curved geometry might actually offer some natural shielding from cosmic radiation.
Oh, like a built-in storm shelter.
Possibly, yes.
Yeah.
Better than being exposed in deep space.
Mm.
And there might also be ways, theoretically, to manage the effects of gravitational time dilation. Time could pass very differently near such a massive structure, so you'd need to engineer things so clocks run normally for the inhabitants.
Right, you wouldn't want your city aging faster or slower than the rest of the universe.
Yeah.
Unless you wanted it to, I suppose.
Precisely. Control would be key.
So visually, what are the concepts? What might these space-time cities look like?
The ideas draw from physics and, let's be honest, some inspiration from sci-fi. You could have maybe ring habitats built inside the wormhole's throat, orbiting or suspended in that weird space.
Like Niven's ring world, but inside a space-time tunnel.
Sort of, yeah. Or perhaps more conventional-looking stationary outposts built right at the mouths, the entry and exit points. Gate stations, essentially.
Acting as hubs.
Exactly. And then there are more abstract ideas like transit hubs, somehow woven directly into the space-time fabric of the tunnel itself, existing as part of the shortcut.
It really does echo things we've seen, doesn't it? Stargate's gates, the ring network in The Expanse.
Interstellar's visualization, too.
Yeah. It's fascinating how these fictional portrayals seem to tap into these very real, if highly speculative, physics concepts.
They absolutely do, which really highlights that core question the sources push us towards. Can space-time architecture ever move beyond fiction and become actual civil engineering for an advanced enough society?
Which brings us squarely to the how, or maybe the how on Earth or off Earth. Because even if it's theoretically possible, the practical challenges must be just unbelievable. What are the biggest ones?
Energy.
Yeah.
The sheer energy required is the first, maybe biggest wall.
How much energy are we talking about?
Physicists estimate that just to create a traversable wormhole, maybe a meter across, You'd need energy equivalent to the mass of Jupiter,
Jupiter, the entire planet's mass converted to energy.
or potentially even more.
That's it.
Well, it's beyond astronomical by our current standards. It dwarfs humanity's total energy output over its entire history by many, many orders of magnitude.
Okay, so step one, acquire the energy of a gas giant, assuming you manage that,
Yeah.
and you have the exotic matter, keeping it stable.
That's the next gargantuan challenge. Stability isn't a one-time thing. You'd need incredibly complex, active feedback systems, constantly monitoring the wormhole's geometry at an unbelievable precision.
And adjusting.
And constantly applying forces, probably using more exotic matter or finely tuned energy fields to counteract any tendency to collapse or fluctuate. It's like balancing a needle on its point forever in 4 dimensions.
Okay, that sounds precarious. And what about living in or near this violently warped, constantly managed structure? It can't be entirely safe.
Far from it. The environment would pose unique and terrifying threats. One major danger is gravitational shear.
Sheer, like being stretched.
Exactly. The extreme space-time curvature could create tidal sources so strong they'd stretch and squeeze anything passing through or residing inside, literally tearing matter apart. Spaghettification, but potentially just from being near the structure.
Not ideal for real estate.
Not at all. Then there's the deep weirdness of causality violations.
Time paradoxes.
Potentially, yes. Wormholes, especially if manipulated, might allow information or objects to travel into their own past, creating paradoxes effects happening before their causes. That could unravel predictability, maybe even reality itself in the vicinity.
So your city could accidentally erase itself from existence.
It's a theoretical risk, yes. And on the quantum level, there's quantum instability. The extreme conditions could amplify tiny quantum fluctuations, causing the wormhole to suddenly and violently collapse, or change its connection point, or just explode.
So immense energy needs, constant active stabilization, risk of being torn apart, potential time paradoxes, and quantum explosions. Seems like a tough sell.
It highlights the scale of the challenge, definitely.
Are there any really out there ideas in the sources about how you might even start this process? Like, how do you get that initial wormhole?
Well, yes, venturing into the extremely speculative fringes. One idea involves quantum foam engineering.
Quantum foam.
The idea that at the tiniest scales, space-time itself is a sea of fluctuating virtual particles and perhaps even microscopic wormholes popping in and out of existence. The thought is, maybe with unbelievably high-energy collisions far beyond anything we can currently do, you could briefly enlarge one of these microscopic wormholes.
And then grab it and stabilize it.
Somehow, yes. Capture it, inflate it to macroscopic size, and then pump in the exotic matter and energy to keep it stable. It's highly theoretical.
Understatement of the millennium. Any other wild ideas?
Another concept mentioned is maybe using primordial relics, hypothetical exotic objects left over from the Big Bang, if they exist and happen to have the right properties, perhaps negative mass or strange topologies. Maybe you could use those as building blocks.
Finding leftovers from the Big Bang to build tunnels in reality.
Like I said, extremely speculative. As one of the reference papers notes, the path to traversable wormholes seems paved with exotic requirements at every single step.
Okay, given all of that, the Jupiter-level energy, the constant balancing act, the terrifying dangers, the maybe impossible physics, why would any civilization, no matter how advanced, even attempt such a mind-bogglingly difficult and dangerous project? What's the ultimate prize?
Because the payoff, if achieved, wouldn't just be evolutionary, it'd be revolutionary. It fundamentally changes the civilization's relationship with the cosmos.
How?
Think about interstellar logistics. Suddenly, the light-year barrier just vanishes. Instead of centuries or millennia for travel or communication, you have instant delivery of resources, personnel, data. Galactic-scale trade becomes feasible. Instantaneous networks across vast cosmic distances.
It shrinks the galaxy down to a neighborhood.
Effectively, yes. It completely rewrites the rules of expansion and interaction. Then there's defense and escape.
Ah, a safe harbor.
Potentially the ultimate safe harbor. A wormhole city, if its entrances are controllable or hidden, could be virtually unreachable by conventional means. An enemy would need their own wormhole tech just to find you, let alone attack you.
Or an escape route if your home system is threatened.
Exactly. A supernova, an asteroid impact, some other cosmic catastrophe. A wormhole network offers instantaneous relocation hubs, cosmic lifeboats.
And for science, the research possibilities.
Unprecedented. Imagine having a station with scientific access right next to a black hole's event horizon safely, or being able to observe faint radiation from the very dawn of the universe up close. Or, if they connect times, directly studying time anomalies. Environments and phenomena completely beyond our reach now would become accessible.
So it's not just about getting places faster, it's about fundamentally changing where you can be and what you can access.
Precisely. The sources frame it well. It's not about building better roads to the stars. It's about tunneling through the fabric of reality itself to create an entirely new kind of interconnected civilization.
Tunneling through reality. But as we've established, that tunnel could collapse or lead to paradoxes or worse. What are the really big picture risks and ethical quandaries if this technology did exist, beyond the engineering failures?
Well, we touched on the risk of uncontrolled time travel effects, destabilizing causality. That's a big one. And a collapse might not be gentle. Gravitational feedback could cause enormous explosions, releasing unimaginable energy.
Like setting off a bomb the size of Jupiter.
Potentially, the energies involved are that scale. And there's another angle. If these are shortcuts, they're shortcuts for anything. Meaning, they could inadvertently become conduits for invasive threats. Something hostile, whether it's a species, a von Neumann probe swarm, or even some dangerous physical phenomenon, could arrive instantly from across the galaxy or another universe, or even another time, without any warning.
Opening a door you can't control who comes through.
That's a definite risk. And then there's the power dynamic.
Ah, yes. Who controls the shortcuts?
Exactly. If one group, one species, one polity develops this technology first, the potential for interstellar geopolitics on an unimaginable scale emerges. Controlling the wormhole network means controlling galactic trade, movement, defense. It's the ultimate strategic high ground.
It could lead to conflict on a scale we can't even conceive of.
Almost inevitably, unless managed very carefully. And then there are the deeper philosophical questions.
About what it means to live like that.
Yes. What happens to your sense of identity, of place, of community, when your physical location in space-time is potentially fluid, changeable in an instant? Does the concept of home change?
Does it lead to a post-planetary future?
Could it? Could a sufficiently advanced civilization eventually detach entirely from planets and stars, existing primarily within this space-time network itself? It's a profound question about the future trajectory of intelligent life.
Wow. We've certainly covered a lot of ground, from Einstein's equations to, well, post-planetary existence. It's been quite the journey through the theoretical physics, the incredible engineering dreams.
And in nightmares.
And nightmares, yes. The huge strategic potential, and also the really profound risks and questions tied up in this idea of wormhole cities.
It really does sit at that fascinating intersection of known physics, extreme speculation, and, the kind of things that fuel science fiction. But it's all rooted, however tenuously, in the mathematics our sources explore.
So, as we wrap up this deep dive, let's leave you with a few things to chew on. Thinking about everything we've discussed, the colossal energy needs, the constant instability, the dangers of sheer forces, paradoxes, explosions, invasive threats, the control issues. Would you sign up to live in a wormhole city?
Is this idea destined to remain pure fantasy, forever locked away in theoretical papers and stories? Or could space-time architecture somehow, someday become a real phase of civilization's journey, just like building cities on the seafloor or in orbit once seemed impossible?
And maybe the most unsettling, intriguing thought hinted at by our sources. If someone else, some other civilization, maybe galaxies away, maybe even in another universe or time has already done this, if they've already built these space-time shortcuts.
How would we, stuck here in our little corner of space-time, ever even know they exist?
A thought that really underscores the vastness out there and the limits of our current perception.
Absolutely. So much we don't know.
Keep exploring these incredible ideas. Thanks for diving deep with us today.